Video. This is for section 6.5. We are going to be finding real roots in polynomial equations. So we can do that by factoring. So we reviewed factoring in the last section. Remember, once it's factored, we can set each factor equal to 0 to get the solutions, okay? So here, if I want to factor this, remember we're going to look for GCF first. So here I can take an x out of all three terms. So I take out the x. What would be left is 2x squared minus 7x plus 3. So now this is a trinomial. A is not 1, so I'm going to use reduce and bottoms up. 2 times 3 is 6. So I'm thinking about numbers that multiply to be positive 6 that add up to be negative 7, which would be negative 1 and negative 6. Okay, now I come through with that leading coefficient of 2 and reduce and bottoms up. So bottoms up with the 2. 6 over 2 reduces to 3. So this is factored, and we bring down that x I took out from the very beginning. Okay, but remember this is set equal to 0. So I can set each of these factors equal to 0 to get my three roots. So the first one is just x equals 0. Nothing I have to do there to solve. 2x minus 1 equals 0, and x minus 3 equals 0. Okay, so I am going to complete the solving for this. So I'm going to add 1 and divide by 2. So x is 1/2, and then x is 3. So I have 3 different zeros for this function, okay? Which graphically means it's going to cross the x-axis 3 times at those 3 places. Okay, so we also have the option I'm going to show you guys on this one of graphing to solve. So I'm going to show you how to do that on my TI-84 and on Desmos as well. So the first thing I'm going to do is I am going to adjust my window. So most of your guys, this is the default. So if it's not, take a second and adjust your window to be these values, negative 10 to 10 for the mins and maxes, and then the scales by 1. So then to enter an equation, we're going to click down here, y equals, okay? And I am going to enter this equation in. So I'm ignoring the 0 for right now, and I'm putting essentially y here. So I want to graph this, x to the 4th minus 4x squared plus 3. So this guy right here where it says x, t, theta, and n, that's what I can click for the variable. And then to the 4th, okay? I'm actually going to put this in parentheses as well, just so the x to the 4th is alone, and then minus 4 times x squared, okay, and then plus 3. All right, so then I'm going to hit graph. All right, so my graph, okay, I can see it's crossing the x-axis, and you guys might be able to see this a little bit better, but I want to see where are the zeros that it's crossing at. So there are 4 different places it's crossing. So you might be able to tell, remember this is going from negative 10 to 10, and each of those tick marks is 1. So it looks like negative 1 and negative 2 and positive 1 and 2. But here's an exact way you can get the zeros from the graph. So I'm going to hit second and then trace. So I'm choosing this calc option by doing that. And then I'm going to choose 0. All right, so I want to get that furthest left 0. So I'm thinking it's about negative 2. So I'm using this left arrow. You guys can kind of see that little blinking guy. I'm using this left arrow to move him along the graph. I want it to be something less than negative 2, okay? So maybe there, negative 2.1, okay? And I'm going to hit enter. And then it's asking me right bound. So now I'm going to use the right arrow to go to the right of that. So anything less than negative 2, maybe there, it's for sure beyond the 0, hit enter. And then it's asking me guess. So it's asking, do you want me to guess where the 0 is? So I'm going to hit enter one more time as a way of saying yes. And it's saying my 0 is that. So yes, that is the place where it's crossing, but we want to give our zeros an exact form. So right now, I'm not actually going to put that here for right now. So I'm going to try the other one. So I'm going to go second calc again, 0. And I'm going to try that next one. So it's saying left bound question mark. So I want to be left of that 0 I'm trying to get. So I think it's about negative 1. So I just want to be something less than negative 1. So sure. Now right bound, I'm using the right arrow to get somewhere to the right of negative 1. So less than negative 1. Hit enter again. Enter one more time to guess. 0 is -1. So that's a nice integer answer, so I'm for sure going to put that one, okay? X equals 0. All right, so from the graph, we have x equals -1. We're not putting the other one because we want to find our zeros in exact form. Okay, we can repeat here. I'm going to show you the next two on Desmos. So this is an app you can get on your phone, or on your Chromebooks, computers, you can click or go to desmos.com and hit graphing calculator. And over here on the left, you can enter your equation. So I'm going to enter that same equation we were working with. X to the 4th minus 4x squared plus 3. Okay, so I see that same graph I was looking at. Okay, and down here, you guys, sorry, my screen's cut off a little bit, but there's this keyboard you can click, and that has a bunch of different math functions in it. So if you're ever looking for something that's not just on your regular keyboard, this has more kind of math type. Okay, so the nice thing about Desmos is I can actually just click on these points and it will give me the zeros. So it's a little more user-friendly than the left bound, right bounds, etc. So this one, and if you click, that point will like stay marked. All right, so these are essentially the same two zeros just mirrored over, so they're positive. So from the graph, we know that 1 and -1 were kind of the nice zeros, okay? That 1.7, -1.7, we want the exact number for those. So here's what we're going to do. After we get our nice zeros from the graph, we are going to divide them out using synthetic division. So one of my zeros is -1. So I'm putting that in the box. Here I have 1x to the 4th, 0x squared, -0x cubed, -4x squared, and then 0x, and then 3. I don't need that plus sign in there. Okay, draw our line, perform synthetic division, so bring down, multiply, and then add. Add. And if it is in fact a 0, I should get 0 for the remainder, right? So here's what's left. We started with a 4th degree, so this is now a 3rd degree. Well, if this one is a 0 of the original function, it's also a 0 of this divided out function. So I actually don't need to repeat the original, you guys. I'm just going to use 1 and repeat the synthetic division with now these as my coefficients, okay? All right, so repeat with this guy. So we're using 1 now. 1 times 1 is 1, add, 1 times 0 is 0, add, and again, we get a remainder of 0. So we know for sure that those were zeros from the graph because when we divided them out synthetically, we got 0 remainder. Okay, so we started with a 4th degree and we divided twice. So this is actually a 2nd degree that's left. So it's a 1x squared plus 0x minus 3. Okay, so the nice thing about this now, this is a quadratic that I can just solve. I want to get x by itself. So I'm going to add 3 to both sides. And then I have x squared equals 3, so take the square root. So I'm going to get x is plus or minus square root of 3. And if you type in the square root of 3, we can see that's where that 1.7 comes from, okay? So this is it in exact form. So all of our zeros for this function are -1, 1, plus or minus the square root of 3. All right. Okay, so in this one, you guys, we want to write this in, or we want to find the zeros. So we, again, can see there's one nice one from the graph. The graph's provided to us on this one. So we're going to do the same thing we did in that last example. We are going to divide out the nice 0. So it appears that -1 is the nice 0, and if it actually is, right, we should get a remainder of 0. So I have 1x cubed, -2x squared, -2x, and 1. Bring down, add, and we do get a remainder of 0. So that checks out. So -1 is for sure a 0. So again, I'm going to kind of write down from the graph, x equals -1. Okay, so we start with the third degree. So after dividing, we're down to a second degree. So 1x squared minus 3x plus 1. Okay, so we can see the other two zeros, but they're not nice whole integer answers, right? So I know it's not going to factor nicely because of that as well, but it's a quadratic, so I can use the quadratic formula, okay? So I'm going to do negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Okay, simplify what's under the square root, so I get 9 minus 4 is 5 over 2. And we can leave it just like that. So our zeros then are -1 and 3 plus root 5 over 2 and 3 minus root 5 over 2. So you guys may have noticed, or maybe you haven't yet, but whatever the degree is, that's how many zeros we should be getting. So in this one, we had a third degree. We got 1. There's 2 zeros here with the plus minus. Up here, we had a third degree. We got 3 zeros, 0, 1/2, 3. On this one, it was a fourth degree, and we got 4 zeros, 1, 2, 3, and 4. Okay, so that is always going to be true, that whatever the degree of our polynomial is, that is how many zeros we should be seeing. Okay, rational root theorem. Okay, if a polynomial p of x has integer coefficient, then every rational root of the polynomial can be written in the form p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. I'm going to be honest, you guys, we're not going to use this a whole lot. We are going to use our graphing technology to help us find the zeros versus this rational root theorem. So get comfortable with your graphing calculator and or Desmos, and talk to your teacher, whoever it is, about using Desmos test mode when you're allowed to use graphing calculators on tests. It is an option that a lot of teachers use. So ask your teacher about it if you really like using Desmos. Okay, this one is important. We're going to use this one. All right, irrational roots must come in conjugate pairs. Remember, conjugates are the same terms, but there's a change in sign. So if this is a root, a plus b root c, then a minus b root c is also a root. So its conjugate is also a root. So we kind of saw that here, right? 3 plus root 5 over 2 and 3 minus root 5 over 2. So anytime there's a radical, we are going to have the plus minus. We also saw that on this other example, that if I had positive root 3, I also am going to have negative root 3 as a root. So that is always the case. So anytime you have a rational number, a radical, that's not a perfect square, we will have the plus and minus will both be a root of the polynomial. All right, guys, that is it for this video. Thanks for watching.